Hi, folks.
Hey, good morning.
Good morning, good afternoon, good evening.
Likewise.
Give a few minutes for people to join. The agendas, as I've discussed last week, I'm hoping Ben will be able to join and do some discussions around the modeling principles that were taken into consideration during the initial Nephew design phases. We'll give him a minute or two to join. Okay, while we're waiting, I don't know, does anybody else, first of all, have any other topics they want to discuss?
Yeah, this is Victor Lu. I'm independent, just joining this for the first time. Since there's not many people, if can I ask a question? Not sure it's related to this meeting directly.
Sure, go ahead.
Yeah, it's about I'm participating more in a CNCF side than Kubernetes side. One topic's been discussing recently is like infrastructure and disaster recovery and all that. I know Nephew in the beginning, it was created mainly for public cloud infrastructure. So I just wonder is for private cloud, I know like Red Hat is also involved. So I don't know, is there any private cloud infrastructure disaster recovery discussion going on?
The discussion is definitely happening. I'm not sure about your assumption that Nephew was designed for public cloud. I think it's what we were using for some of our tests because it's what we had available. We're actually extremely interested in private and hybrid cloud. I think our challenge is finding for private cloud is finding the lab infrastructure for testing, but it's yeah, and Red Hat is involved and definitely looking at OpenShift in hybrid situations. So it's a high priority for sure for telco and for us.
So the infrastructure layer, whether it's virtual machine or bare metal, is there already like a supported list, or is there which meeting discuss about that?
There is no. We're not at the point of having support. You can think of what we have right now with Nephew release 2. That's the latest release as a reference implementation. if you target Kubernetes, it should work on any Kubernetes, but you're right that it needs to be tested as well. So we have Wim here, who is leading infrastructure team. And we have a use case for service assurance, which I think would be closest to what you're calling disaster recovery. And as part of that use case, we are exploring also aspects of infrastructure failure. Yeah, I would say that if that topic is of interest to you, I think the service assurance use case would be where we discuss it. We also have an observability group, but yeah, it's driven, I would say, for now by the service assurance use case.
So the assumption will be any infrastructure, whether it's VMware or OpenStack or bare metal, is all supported, right?
Yes, although the actual support we can offer depends on how people contribute and if they flesh out that specific use case, right? So as you said, Red Hat people are very involved in Nefio, so I expect them to create a robust OpenShift scenario. VMware less, but if we have people from the community who will invest in creating a VMware testing scenario, then we would have that.
At least at this point, there is no such a effort yet.
The effort is there, I think, especially with the Red Hat folk, as you mentioned. And here at Google, I'm from Google, we're using GKE, which is our public cloud offering, but I'm on a team called GDCE, which is Distributed Cloud Edge. And we have specialized hardware that we use for private scenarios. So, and we also have a product based on that. So that is the fullest support you can get right now is for GDCE. Yeah, it does exist.
So for GDC, what is is it bare metal? Because since it comes from Google, I guess that's the assumption.
Yes, it is bare metal. Okay, we're drifting maybe away from where this meeting should be right now, but yeah, it is bare metal. It is an interesting solution in that it's not bring your own bare metal. That is a different product that we call GDCH hosted. GDCE Edge is you do get the bare metal from us. We have a few configurations that you can purchase, and which are fully and very highly supported. So it's not bring your own metal, it's buy your metal from us, from our partners. And we have a limited number of configurations that we support. Interesting problem. Yeah.
Good discussion. And I guess, Victor, the service assurance meetings, I think they're on Thursdays at about the same time as this meeting. Maybe is it an hour later? And I think so that might be the best place to start that conversation up.
Yeah, you're really just so many people in a Nephew meeting that, so I just take this chance to ask the question here. Thank you.
Yeah, no, that's fair enough. Okay, so the agenda for today, thanks Wim for joining. We had on the agenda just the one item, so we want to discuss the modeling principles and trade-offs that we're taking in the original Nefio design, and Wim volunteered to put something together for this to start the conversation. So I think you shared a synopsis of that in the chat with me in Slack. Wim, I don't know if you want to share it.
Yeah, I can share my screen if you want, so if that's okay.
That'd be great, thanks.
Yeah, so I just, do you see my screen?
Yep.
Yeah, I actually created a design.md file in the API, so I don't know whether that's the mode of operation, but I just, yeah, so probably it's not complete, but I try to put some discussion in, right, in terms of API design. So, and we can discuss the format. I just said, okay, let's have something going, right? So that where we have some description on, or at least documentation of some of the things that we did. So first of all, I started with the package, right? Because although it is perceived as an API design, it is, in my view, also relevant in this discussion, right? Because there are some specific elements here that we are using and where our APIs are also structured around to a certain extent. Okay, so I just copied from our documentation, so this should not be, I don't know whether you agree, but so a package. So basically, what is a package, right? It's a logical grouping of Kubernetes resources, right, or templates. And I think from my perspective, we have basically two classes of packages. One is what we call catalog and other deployments, or also called dry versus wet or wet, right? And now, if you then I drilled a little bit into what a package actually is, right? So because there is a few more details that are important. Now, these are implementation-wise, they are somehow a little bit implied by kept, but they don't have to be. But so at the moment, I use the kept, let's say, mode of operation to define it, right? But that doesn't have to stay necessarily like that, right? But in essence, if I look to a package, if I go drill one level deeper, then I would say at the first level, we basically have two sets of resources or KRM resources into it. So maybe I should call it KRM or Kubernetes, or yeah, so let's call it KRM resources. So one are what I call local. So they are in the package, but they are not necessarily actuated anywhere. So they just are there to provide context. And then there is what I call output, right? So it's actually the thing that where config sync is then that config sync or whatever GitOps system that we could use picks up and is going to define or going to actuate. So how do we distinguish between those different resources is with this annotation, right? So this is the annotation that we use to distinguish between what I call local and what finally goes, can be used outside of that package. So that's kind of one element. The second element is that so from an output point of view, there is not much more to be said other than that, I think. But for the local resources, there is some more information that I think we have to highlight, is that there is different types of these things. So one is what I call input or even injector placeholder. So we actually add KRM information as input. So, and there is various types of inputs actually I did not highlight. So for example, we created a context of, actually I had it here, of what we call requirements. That is a type of input that we use to then actuate or use during the hydration or specialization process. So maybe I should add that, right? So there is requirement CRs that we inject. So an example of this is, for example, the interface, right? And the requirement for the interface says, for example, I need a VLAN or I don't need a VLAN, and stuff like that. So that's what this thing does. The second thing that we have here is placeholders for injection, which are also another type of input. So this is, so you could call it dynamic input, that we are going to fetch or find somewhere that eventually gets added to the package. So this is to give more dynamic content. So these requirements at the moment, they are rather, you could say it's static, right? So there is static input, which are, for example, requirements, I think. And then we have dynamic input, which are what we call injections and so on, right? So that's kind of what we do. The second thing that, yeah, go ahead.
So when you, so why do you call these requirements injector placeholders?
No. So they
And-
are.
So it is under, at least in this, yes. So is it, so it's not an input, is it? Or
The
maybe
requirement is, in my view, an input, because it's an input for, it's an implicit input in the package, because that information is going to be used to get to this result, right? And
is it
you see-
coming from the outside of the package? So is it injected, for example, via a package variant?
No, so that's why what the difference is between static versus dynamic input. Static input is basically something that we or a designer has added to the package without, and that is not going to be, there is not going to be variations around that. So here, the variations that you have here are, so there is no
Okay.
variation. Whereas
Now
here, the dynamic input is what you can basically modify during with variations.
Now I think I understand what you mean. You mean the DNNs and interfaces that we are putting in, for example, in okay, I understand. I think that here we are mixing the input for a package and inputs for the KRM functions that are applied to the package, and we should think about this.
Yeah. So okay, I'm at the moment I'm just trying to identify what we did. I think there is if you look to the pattern that is here, you see that you can improve this quite a bit, I think. But what I'm trying to do right now is document what we have. Okay, not what we should do, but what we have right now. That's kind of the goal.
What I'm trying to do is to explain it in a way that is less confusing for beginners. Now I understand, I think, because I was there. I now I know what you mean. But again, I think it would be more clear to separate that this is an input for a kept package, and an input for a package for me is what you call a dynamic input, and there are other. There are resources in the package that are inherently there, that are put there by design time, that are inputs for the KRM functions, but that is basically any resource in the package can be that. Isn't it the case?
Yes, now I see. So this is a bit, yeah. So for you don't see this as inputs because it's static, but there's nothing preventing us from making that dynamic going forward. So it's just, and I still see it as input, because if I would put two interfaces in it versus 3, it's different input. You see, although it is completely statically defined, and I think any mechanism that has, so I'm of the opinion that going forward you have what I would call these defaults. And then you have variations. So, and any input that you define into your package, you could either override. That would be my view of how we should move it going forward. But what we did right now is we have certain input that is never going to vary at the moment. And there is input that is varying. And so we differentiate between them. And I think I don't see why you should differentiate. They should be treated in the same way.
Okay.
But at the moment we distinguish between them.
Okay, go on, Kieran.
Yeah, maybe this is a very, very, very basic question. So when you say a package has some assumptions, do you mean a package has some contents, or are you describing here different types of files in the package that are defining KRM resources, some of which are local?
Static KRM, so input is, so anything that I'm trying to describe is KRM resource. So for example, if you look, let's take an example of, where is it?
But okay.
So do you want me to show an example?
Yeah, go for it. Yeah, I think an example would be good.
Nephew catalog. Right. GitHub machine project. if you look to the catalog, right? So you have workloads, for example, right? Take FreeFireTC, AMF, okay? So what you see, for example, static input that today isn't varying is this, for example. So that's for me what I call a static input. At the moment, there is no way to vary this input from this package. You
Okay,
see?
that makes sense. And it's also, I guess, when you have that config.kubernetes.localconfig.io/localconfig, that basically means don't create a CRD out of this.
Wait, so that's okay. So I'm coming to that, right? So
yeah,
that's by default the way that we are using it, right? But for example, okay, what you don't see here is if you look to the functions, right? So I call this an input, right? So this is used as an input to get to a final result, okay? So I see a package is the same way you get input and you have at the end of the day that's going to be output, right? So the output is what eventually goes to the next stage. The input is basically used to actually, in theory, get to the output. It's something that you need. It's like a function, right? The function has an input and then you have an output, right? And then the package hydration or specialization that we use uses the input, and all that input is going to then have a contribution towards the output at the end of the day. If the input would not be used to get a contribution to the output, it's useless at the end of the day, right? It could still be there, but it will not be used.
Yeah,
so,
okay.
So that's my,
but there might be some
high level. Yeah. Now, what I wanted to say, Kieran, is that this CR as such is indeed never actuated anywhere, right? But for example, what we are doing in specialization, as an example today, this input is used in a function, right? And that function can either be implemented through a kept function which will run in the cluster, but can also be actuated through a controller. So for example, take the IP addresses or the VLANs and stuff like that. There is, it could result in a CR in the management cluster but not this one, but a derived object from here.
Yeah, that makes sense.
You see?
That's, yeah. So what you can do is you can have a package that contains just local config, and then that local config is run through a pipeline of kept functions or used as input to an operator, which then creates custom resources that are actually put into the Kubernetes API.
Yeah, so I see it I see the package really as a function, right? So you have an input, it has business logic, which is the pipeline at the end of the day, right? And then you generate an output, right? So that's kind of what happens. Now, as part of that business logic pipeline, you could generate other CRs, right? That are going to then be actuated. So the input as such is not actuated, but the pipeline or the business logic that is used to hydrate that package could be.
Okay.
Right?
Tal has a hand up.
Yeah, I wanted to try maybe I think the terminology has confused some people. So I want to try maybe another approach to explain this. So Wim is calling it inputs, and I think that's confusing people because it's more of an interior input, right? It's not something that a user of a package can input, although they potentially can, as Wim points out. I think maybe a way to think of it is maybe not call it input. The idea is that the package can comprise of CRs that will be scheduled as is. Wim calls it actuate. That's a good way to say it too. So some of them will be scheduled as is. Some of them have to be processed first to create the scheduled resources, and they'll be processed by kept functions, right? So the CR we just saw is not going to be scheduled as is. It's going to be, this is actually a configuration for a kept function, right? That's kind of the point. Yeah. So the package is reportedly ready to go, right? To turn it into a deployment, some of these CRs will be consumed by a kept function and new stuff will be created or modified elsewhere, right? So that's kind of the point. So they are interior inputs. You can think of it for kept functions, but even if we don't think about kept at all, right? If we do a controller-based approach, right, that will read these, so it's not input, it would be a reconciliation, right?
And
Point
then
being,
this would be the 4 CR that on which the controller is running, right? So that would be
yeah,
the CR of the 4 CR that is used to trigger the reconciliation.
right, right. Yeah, so I think that's the point. So I'm not sure if input is the best way to describe this. It is, you know, technically for the cat function, but I wonder if in our description we can think of, you know, these are specialization configurations. Yeah, anyway, I hope we understand, everybody understands what this is, and then we can think about how to explain it in a diagram.
But maybe we call them configurations or something like that, or
The thing is, everything is a configuration, right?
Yes, correct. So because I see a difference, I distinguish config associated with the pipeline because I really see this is actually, if you really look at programming, it's actually it's an input to a function at the end of the day. And the way I see it is the package is the big thing, right? And you have a bunch of, let's say, input resources that are going to be used to derive an output, right? Now, at the package level, because it's a container, if you will, of many things, you see various input. Maybe there's a better word, but I see it as input because I associate it with similar to a function. And so it's kind of a struct of various CRs as inputs. And then the package, which is then the business logic, is going to say, for this input, I'm calling another function within my business logic that is then using this as an, only that CR as the input to actually get a result from there, right? And that can result in additional CRs that do then so on to get to that final result. So it's kind of really like a program at the end of the day. But maybe my description is wrong, but that's kind of what I try to depict here.
I think it's going to be difficult to wordsmith it perfectly, but it sounds to me like a kind of a diagram might be useful. I can volunteer to start one if.
Yeah, I have a visual in my head, so I can do something in draw.io, right? So where we can try to make a bit of a picture. So I have something in my head that maybe could explain it better, but I didn't have the time to put it together.
Yeah, that'd be cool. If you don't have time, I could throw together what I think you're saying, and then we could iterate on that. But if you want to, it's probably better coming from you to start with.
Yeah, and then we can, at least to have the concept hopefully understood, right? And then we can also change the terminology. I don't have a problem. Because it's, and we can call these different inputs or something like that, right? Mm-hmm. But yeah, and this is just a draft, right? So I think, But I distinguish.
Yeah, go ahead.
Sorry, no, go ahead.
I was the word assumptions up above. I mean, is this the package has some contents or?
Yeah, okay. So it's basically the way, it has some, but the way the assumption is the implementation. So like how a local resource is identified and stuff like that, right? So for example, so also the pipeline is how it is depicted is it's actually specific to how kept. So kept based uses a certain way to do so. Mm-hmm. That's what I was trying to say with the assumption. A package has some, a package, So so maybe I should just call it package content, right? And then implementation, right?
Yeah, that's cool.
Implementation is
compliant with kept.
Yeah, implied with kept, basically.
Or compliant or.
Yeah. Or here, right? But so just to come back to Isti's point, so the difference between static and dynamic, if you go back to the example, so I call this static input because there's nothing who is varying it, right? Then you have workload cluster. Here you have this annotation. Maybe I can also put this. This is actually something that can vary. You see, if the injector run. So here, this is what I call the placeholder. So that's why I distinguish between two types of input here. One is this static stuff, and this is the thing that actually varies with the package variant.
Wim, I think you summarized very well the difference between your way of thinking, and I think I understand it, is that you think of a package as a program, and
Yes.
I think of a package as a declarative descriptor of something. And that's, for me, it's a bunch of configuration, as Tal said. So for me, okay, in this package, for me, that we have the package that you have showed, it describes an AMF that has, I don't know, 3 interfaces and whatever else is in the package. And for me, is not an input, that is a current state of a package. It is, I can think of it as a big CR, a big Kubernetes resource together, or something like that, while you are thinking more like a program, as you said. And that's why you think that the static, that you call a static input, is an input, and why I think it is just part of the package. It is just okay. That's it. That's and basically we can talk about which interpretation is more accessible to newcomers.
Yeah, correct. And it's a good point. I mean, yeah. Now, I do believe, by the way, Isti, right? So that's what I try to say here, right? Or I didn't do it properly, is that you could obsolete all of this, and then you get what you say. So if you would actuate it, the whole content. So a package doesn't have to have all of these resources. So they are optional at the end of the day. I forgot to add it. So these things, so this input, as I call it, is actually optional. The pipeline is actually optional, right? So all of these things are options of a package as how I see it. And if you, for example, don't include any of this information, then if you apply the package like you said, you will actuate it. Now, if you would apply a package on a cluster with this, as is not through config sync, you will fail. This will never work.
Yeah, you mean not through KPT, or so if you don't run the pipeline
no, not through config sync. So not through a system that understands this.
Oh yeah, yes, true. Yes, okay. Yeah.
So in other words,
it's just a dialect.
Yeah.
So all GitOps tools have the equivalent annotation for this. So yeah. Actually,
the
we
other
can
thing
even
is that,
teach Argo CD to respect this annotation.
Yes, yeah, correct. So, but
I
what I'm
think
trying,
Tal's hand is up for a while.
Yeah, okay.
Just saying.
Yeah, okay. Sorry, I don't see them. Yeah.
So I want to point out, that I think the terminology is going to be an ongoing discussion here, and I think it's very interesting, actually. I haven't finalized it in my own mind, the terminology, but that Isti raised the point that thinking here as a programmer. I would say, unfortunately, we do have a mix of declarative and imperative thinking in packages right now, and that's due to the pipeline. I don't like it. I was opposed to the pipeline from the very start, but it's our inheritance from kept. And I don't like it because it puts, when we think declaratively, we don't think of order. We don't think of sequence. There's a whole bunch of KRM in the package, and the order shouldn't matter. However, when we deal with the specialization process, it is, think of it this way, specialization is something that begins and ends. It's not reconciliation, because once it ends, the package is specialized. No more specialization occurs right now, and now it goes to deployment, right? So, and that thing could be described as a pipeline. At least that's how we do it right now. And I think both Wim and I have ideas over removing that because I think we find it uncomfortable that a pipeline is there. So unfortunately, I would say the pipeline does have an idea of inputs and outputs, right? Because every kept function on the pipeline does that. But I think there's a better approach. I actually prefer your approach, Isti, not thinking as a programmer here, but thinking as an architect. And as an architect, you have a mix of resources in a package. Some of them, this is why I sometimes use the term meta scheduling, right? We schedule some resources as is on workload clusters. Some of them might have to be scheduled on a management cluster. Some of them are not scheduled anywhere. They're used as these configuration for the KRM functions or plugins in my case, right? So we create a package is a declarative front end. So here's another way of thinking of what a package is. It's a declarative unified front end for lots of different subsystems. It's infrastructure configuration, right? It's workload configuration. It's specialization configuration. It's metadata configuration. In some cases, you might have metadata that doesn't speak for anything. It's just descriptive. It describes how this package exists in the universe, right? So all of these different things can exist in a package. I mean, this is what some people love about the GitOps approach, and I'm not a GitOps person, as you well know. But what GitOps does, it takes a lot of disparate systems and puts them under one repository, right? So you can have a Git repo, which has, Terraform descriptions, it has KRM, it has an Ansible playbook, all these different subsystems that work differently, but you unify them together under a Git repo. With Nefio, we've decided that only KRM is our language, which is very smart. But a package still involves all these different, it's KRM, but for different subsystems, right? So that's what a package is. It's a declarative unified front end, right? Anyway, I hope that inspires some other thinking. Go ahead, Kieran.
Oh, forgot what I was going to say now. Never mind.
Yes, I agree. It's a declarative. I think we should. I also don't like the way the pipeline is. But at the end of the day, if you look at the content of a package, in my view, it's a collection of these things, right? And whether you have this or that or that or that is an option of the package. So in other words, I was trying to start here. At the moment, in my view, we have basically two sets of packages. So these software-centric packages, they have none of this. The config-specific packages, they do have all of it. You see? So these packages here, they don't even have any specialization.
But right now, but is it an inherent thing that Multus package cannot have, or
no,
it wouldn't make
I'm not
sense
saying
to
it cannot
have
have. I'm not saying it cannot have. I think what I'm trying to say, it doesn't have at the moment, but it could have, but it doesn't have it at the moment.
Yeah, that is just exactly. So I wouldn't separate them as such that they are I don't see them inherently different. For me, SMF and config sync, both of them are basically applications. Maybe one of them is a bit more complex than the other, but at the end of the day, it is something that we want to be deployed on some compute resources.
Yeah, but let me rephrase what I'm trying to say, right? The fact that we call out these attributes of these resources, in my view, is going to be important. Because there will be resources that we put inside that are, let's say, used as context or input to do something with. There will be resources that will be used in a declarative way, in my view, as a way to convey the pipeline and stuff like that. So in my view, for someone who wants to build a package and define the content of the package, in my view, it would be good for people to understand the attributes that Nefio defines within it. How we then do it is a different discussion, but I think we have to call out the attributes of the resources that are contained within a package. They have a different meaning. And that's what I want to call out here. The meaning of these resources will be important when for people that author a package, how they should, what they are and what they could be, and how they should could use them.
I think, okay, so I also think that maybe I'm not sure if it is worth spending so much time on nomenclature, because I think we understand what is happening under the hood. We are talking about how to name things, but I have still one thing in my mind. So I think that what I liked in Tal's approach is to think about, what if we remove the pipeline? It seems that we have a common understanding in this, that it would be a nice thing. And let's just assume or imagine that the pipeline was already removed from it, and we have some ways to transform a package to another package, and we have these steps so far still, but we will apply it from the outside, that we will apply transformation and create from one package, we will create another package, and we will do that until we, and we will stop this process somewhere. And if you see it from this perspective, then any KRM resource in a package can be modified. You do not know, just looking at the package, that what the next transformation will be. So you do not know that which resources will act as the input of that transformation, and which resources will not. And for example, or to give it one step further, so is it possible that sometime in the future, if we have a hydration process, then we will stop the hydration process in an earlier state and make all of these KRM resources that so far were local KRM resources as something that will be deployed down to a Kubernetes cluster. And now it will be, the process will be continued, not as the hydration process, but it will be taken over by, let's say, traditional Kubernetes operators or controllers. So I mean that it is arbitrary that to say that this resource in the package is an input and this other one is not. It depends on what transformation to be applied at the package. Yeah. And if you remove the pipeline and look at the package, then you don't know what the transformations will be. I hope that makes sense.
So Isti, I mean, any reconciliation, that's an input for, any KRM can be considered an input for a reconciliation, right? So the word input is just the most neutral word possible, right? That
yes, but yeah. Yes, that's my point. If everything is a static input, then it is not a distinction anymore.
No, yeah, but see, what I think we have to ensure is that the package output is idempotent. Okay, so that means if I have a certain input, right, the output will always have to be the same. That is something that I think is going to be important, because my view is, okay, so in other words, the way I look at it, I see a package as something that has input and output at the end of the day. Input can be optional, by the way, and output is there, right? Because otherwise, why do you define it? Okay, but so it doesn't mean, so we could easily build a system with what we have, that the output of a package is used by another thing, and then another thing, and then another thing, and another thing. So the amount of cycles or hierarchy that you put, I don't want to define. At the moment, we have only two. We have something in the management cluster and then the workload cluster, but you could have 10 stages if you want. But each package, I think it's important to determine, to define what its input is and what its output could be, right? It doesn't mean that, but the output will depend on the input, and if you don't give input, the output is deterministic, right? And it's also, if you give the same input, the output should always be deterministic.
Okay. So for me,
to point out, it's not always so. I think we should distinguish. There's pure specialization that would be deterministic, but a lot of times it would depend on something external. I mean, even something like IPAM, you're going to get a different address every time according to what has been distributed. So it
not
might
necessarily.
Not
that depends. Yes, but so if you build an item, wait. So what is wait, so let me, yes, if you build an idempotent system, it should be the same but if you run it again, it should be the same, but there is derived configuration, right? But yeah,
Right.
so that you can have, right? So there is derived configuration, but I don't exclude that from this definition, if you will. Because
yeah, I understand what you mean by idempotency. It might not be attribute idempotency, but it's
correct,
functional idempotency.
Correct. So you will always get an IP address, whether it's the same or not doesn't matter. You should always get one, because otherwise your context changes, and in that case, of course, it will not be the same, or it could not be the same, or it could be that you don't get it.
Yeah.
Right.
I
But
will
it's the
mention,
same with the program.
Yeah. I think I understand what you mean. That's why I called it functional idempotency, right? But you know, we do have, like, this whole approach is very new, I think, and original, and you know, we're still trying this out. One thing that my experimenting with this so far, I think our biggest challenge is handling errors. Right, if you assume automation at a very large scale, and you know that all these work without failure, then that's great, right? But the question is, what happens if something in the specialization pipeline here doesn't work well and there's an error, and then the error happens at a very large scale, right? And I'm not really sure how we can deal with it yet. We don't know exactly how to deal with it yet. It's fine if it's just one package that we're testing as part of validation. But the question really, what happens when things don't get exactly deterministic, or, you know, if an IP address, I don't know, the same IP address gets distributed twice, right? Something like that. There's a lot of room for mischief in this process at scale, which I don't think we figured out entirely. You know, we can talk about inputs and outputs, but we're not really talking about validation, right? I mentioned this a few times. How do we validate these packages, not only in terms of their static data, but in terms of their specialization behavior? Yeah.
The failures today we cover,
for example, right? We don't do that. An input is known, but a ket function can do anything it wants. It can change the entire package. And yeah.
But so that's, I think today, okay, there is multiple errors, but two sets of errors. One is where the specialization fails, right? That we cover today, because there is so in the conditions we basically tell the reasons and stuff like that, why that happens, right? So that, you know, of course, what the second thing that we do not do, because we do auto approval, I mean, is that the result that we get out of it, we should actually run through a validation pipeline, which should trigger these errors that you were mentioning. That we don't do at the moment.
Yeah, I do that in my
do.
PhD, right? But that's like KRM validation, right? And anyway,
but you can do behavior, right? So if you get the same IP address, you will see that it will fail.
oh yeah,
right?
yeah,
So that
you can potentially do anything, right? But you know, until you actually deploy the package on the workload cluster, yeah, my point is, yeah, we can see errors in the logs, but we.
No, there's even an error in the KEP pipeline. There is a condition that will tell you why it failed.
Yeah, you can get it in the status. We can debug it. My point is about validating, for example, that inputs and outputs are the same type. That what are the potential outputs, right? Because what I'm trying to say here, we're talking about inputs. We're not really talking about outputs, right? We're not using the word output, but it is there implicitly. There is an output from KRM functions. Oh, you did, yeah, you did list it, like, but. Yeah,
I'm talking here at package level, right? So I'm working at package level here. There will be an output from at the package level. We are not talking at the function level here at the moment. This is at the package level.
Right. Anyway, sorry, Kieran. Yeah, you want to jump in?
Yeah, I just wanted to. I mean, I guess looking through some of the existing packages, there are resources in the packages that we have in the catalog which don't have this annotation set, and therefore they contain outputs.
Yes. So if you don't set anything, they are considered output by default. If you even don't set it, I agree. And that's So we do that that's why these ones here, because these are a bit at the moment special for us, because we just take in whatever Multus defines. We have to transform it into kept, which is another, I think I would say, disadvantage of kept, right? So you have to make it keptish to get it. But in theory, you're right, is that by today, if you don't set and maybe I have to add this, is if this is not set, right, then it will be considered output, right?
No, I think that's fine. What I was wondering in terms of, I don't know what your target audience for this document was, Wim, is this for people who would, be coming to Nefio and looking to design a package that they can then onboard, and would we be putting together principles to support Ericsson or Nokia network function developers to design packages for their workloads, for example? Or is it for us as architects to develop?
My first goal was to agree between ourselves, because you see that but eventually I think the goal is to make this part of our, where it fits, I don't know. It could be
So I started working on in the official
design or something.
Yeah. Maybe in the upstream documentation under the docs repo, I started to move some of the modeling descriptors in there, and maybe we could have like some of this content in a sub chapter within the overall documentation repo.
Correct.
But I think in that context, I think it would be useful if we could sort of point people at it to say, if you want to onboard a workload or whatever into Nefio, here's the overall principles around how to do package design, and then maybe we can have examples underneath that then of specific types of package for different workloads, maybe as worked examples in the future.
Yeah, correct. So I think first of all, we have to agree on the terminology and the description, right? And then, but the ultimate target should be I think this is here to onboard new people and to make a better understanding of how it's used, such that people can design these packages by themselves, for example, right? So that we give some guidance on it. So that's the ultimate goal, but it's definitely not at that level, because I said, okay, let's first discuss the items between ourselves, right? Because you see that we still have some discussions on it, right?
I think it might be worth maybe putting a section down at the bottom then, where you discuss maybe limitations and future plans. So, for example, where we explicitly say that these are things that we don't cover or that we want to change.
Future, I didn't want to get
future
there
improvements yet, or something.
Yeah, but I wanted to, because they should at the end of the day be. So the question is this what should we document that inside of this stuff?
I think even in terms of this conversation, I think it's useful. I mean, the idempotency aspect, the troubleshooting versus debugging and status reporting, do we keep the pipelines? Do we get rid of the pipelines? Declarative versus imperative and so on. Those types of things we can just capture here, and then, so that the KRM package description up above can be a pure description of what we do now. And then when we say, well, actually, maybe we shouldn't do that, or maybe it would be better, then we can describe that down in that chapter. If that makes sense.
Okay. Yeah, just between us, because okay.
And then that becomes like a wish list for R4, R5, etc., until we stop using release numbers for the.
So there is more, but I don't know whether we have more time to start on other stuff, but there's probably less contentious this thing, I think, because this is
there's 5 minutes left anyway, so.
Correct. So the question is, what do we do with this? Do we see? I put right now. I put it here. I can make a PR on API. So I added in the Nefio API, and I made it a design MD document in the main folder. That's where what I did, but I haven't committed. I haven't put a PR inside.
So I started doing some work on a branch in my, I forked, I haven't made a PR yet, but I started doing some work under the Nefio docs. So we could work on a sub-chapter there, if that makes sense.
Okay,
Or
so
I
you
don't know
prefer to
what-
have it there, okay, which is fine. Yeah.
I don't know if I'm agnostic really, but I think it would be nice if it was at the top level and under the docs, maybe as part of the architecture description or something like that, in order to steer people to one place for this type of documentation instead of having to go all over the place.
Yeah. Or we refer to it here, right? Because at the end of the day, this is where the code lives, right? The eventual code lives.
Yeah. So I don't know whether there's plans for the documentation to host it in lots of different places, or whether it's supposed to be all in one repo. But I know in NoNap we had each repository had its own docs, and then there was a process to pull it all together under one big umbrella. But I don't know if that's the plan here. For now, I put it under the API docs, and then we can.
Okay, I'll put it there for now. Yeah. Because anyhow, there is a mix of packages which are not here, right? Which is probably doesn't belong here, but this would belong to the cat. I would be a fan of having a docs in every of our repos, because that's eventually where the code ends up, and then a process in the docs that pulls it from there and generates. That would be I would advocate for such an approach, because I have the feeling that event like this design here, right? So we discussed, for example, the workload with discussion, right? The principle today, okay, I did this slides at some point, but it's nowhere documented. So people who are not involved, they don't know.
Yep.
Right. So the only thing they can do is can look to this API document and see, okay, what the hell was done, but they have no clue on why we did it. You see?
Yeah, exactly. Yep.
So that's why I would say it belongs. I think for me, the content eventually belongs to the places where we put the code. And I mean, that would be, I don't know what other people say, but advocate for an approach where we then collect all of these various snippets and generate. Of course, we probably need to put some context then around it, but at least the content is pulled from there. And then there is some context around it that helps understand what they mean. But
yeah, I can maybe start a conversation with the docs team about what their plans are there to see whether they have a plan for that. In the meantime, we can iterate in the API repository
in the docs. Yeah, no, that's fine. Yeah, I'll put it there for now, and then we can always see what we do. Yeah, but I think it's good that we capture, and then people can comment, right? So let's comment on it, because that's how we can probably iterate and improve also on the way that people perceive the descriptions. Yeah,
that was really good. Thanks very much, Wim, and great discussion.
All right.
Any other comments or questions before we drop?
One very quick comment.
Yeah.
Question, sorry. Okay, I just wanted to ask, have we ever considered using as far as I know, there is a way for Kubernetes, for the Kubernetes API reference documentation automatic generation. Have we looked into if we can use that to generate a reference documentation for our similar APIs from the Go code?
I did look into that.
I think.
Yeah,
we do that, I think, right?
Okay. Sorry. That
you
was
mean
the question. It's okay.
So Isti, you mean the reference API documentation, not the relationship like what Kiran?
No, not the relationship, but I believe the reference documentation at least is auto-generated for the Kubernetes.
That's correct. Yeah, that's correct.
For Kubernetes API. So not the relationships. For the relationships, I think that we could use, if we can look into the code of controller gen that is used by Kube Builder and the operator SDK. Most probably we can use that code to maybe add our own notations in comments for the relationship and generate some, I don't know, mermaid diagrams from that. But that is a big project. So that is definitely not ready-made.
Yeah, I demoed some aspects of that a couple of weeks ago, Isti, in this meeting.
Oh, sorry.
No worries. I can share
I'm
the
missing
output.
so many meetings. Sorry, I have too much on my plate. Sorry.
yeah, I think there was a number of trade-offs with that approach that and we kind of went back to doing it by the by hand.
I just wanted to ask you. You looked into this. That's my answer. Thank you.
Yeah, it did indeed. Carl, did you have a comment?
No, sorry, just saying thank you to Vim.
Okay, very good. Thanks very much, folks. Great discussion, and enjoy your weekends.
Thanks.
Thanks,
You
everyone.
too. Bye.
Thank you.